Okay, let us discuss the answers for model question papers. Here I started from part A. In first main we have multiple choice questions. Our first question is the electrostatic force between a pair of unlike and like charges respectively are option A repulsive attractive, option B attractive repulsive, option C repulsive repulsive, option D attractive. Here they asked electrostatic force between a pair of unlike charges, means plus and minus, charges are plus and minus. So what is the electrostatic force between them? So we can say it is attractive and repulsive. It is the property of charges. So here the answer is option B, attractive repulsive. Question number 2. The electric potential at the surface of a conducting charged spherical shell of radius 10 cm is 20 volt. The electric potential at the center of the shell is option A 0, option B 10 volt, option C 20 volt, option D 30 volt. Here they asked the electric potential at the center of the shell, and we can write the given as radius of the shell is 10 cm and voltage is 20 volt. So the electric potential is constant. We know that electric potential is constant throughout the volume of the shell. Therefore electric potential at the center is 20 volt. Here the electric potential is constant, so they ask the value of electric potential, V value. So we know that it is 20 volt then. So option C is our correct answer. Next question, question number 3. As the temperature increases, resistivity of option A metals increases and semiconductors decreases, option B metals decreases and semiconductors increases, option C both metals and semiconductors increases, option D metals remains constant but semiconductors decreases. Here the temperature is directly proportional to resistivity of metals. They said that temperature increases, so what happens to resistivity? We know that temperature is inversely proportional to resistivity for the semiconductors. So what happens? Metals increases and semiconductors decreases. Option A is our correct answer. Next question, question number 4. A charged particle is moving in a circular path in a uniform magnetic field. Then choose the wrong statement among the following. Option A, radius of the circular path varies directly with its velocity. Option B, radius of circular path varies inversely with the magnetic field. Option C, frequency of revolution varies directly with the charge. Option D, frequency of revolution varies directly with the kinetic energy. Okay, we have to find the wrong statement in these 4 statements by using, they said, radius of circular path. So we know that radius expression R is equal to mv by bq. That is for writing for frequency, that is frequency f is equal to bq r divided by m. Next, using these 2 equations, what we can say, the frequency of revolution varies directly with the kinetic energy. So option D is our correct answer. Okay, next, question number 5. A magnetic dipole of magnetic moment m vector is placed in a uniform magnetic field B vector such that the angle between m vector and v vector is theta if the magnetic dipole is in stable equilibrium position. Then option A, theta is equal to 0. What is theta value? We have to find the value of theta. Option B, theta is equal to 90 degree. Option C, theta is equal to 180 degree. Option D, theta is equal to 45 degree. Here we know that torque tau is equal to mb sin theta. They use magnetic moment as well as magnetic field B. And also we know that when theta is equal to theta is equal to 0 degree for stable equilibrium and theta is equal to 180 degree for unstable equilibrium. In this question they asked for stable equilibrium, so we can say our answer is option A, theta is equal to 0 degree. Question number 6. The dimensions of inductance is, option A, B, C, D are given. Which one is correct? We have to choose. So they ask the dimensions of inductance. We know that inductance is denoted by L. So we have the expression for energy stored in the inductor, that is U is equal to half Li square. So we want the expression for L, inductance. So I will rearrange that expression for inductance, that is L is equal to 2U divided by I square. Now I want to find the dimension of inductance. So I will write dimensions. We know that dimensional formula can be written in the square bracket. So I'll write L is equal to, here 2 is constant, so I didn't wrote constant. My equation is L is equal to U by I square by neglecting that constant. Then we know that U is the energy and I is the current. So dimensional formula for energy is M L2 T minus 2 and for current is A square, A2. Now what we have to do, we have to shift the term in the denominator to the numerator. So what happens to A plus 2 becomes minus 2, a to the power minus 2. So we got our expression as L is equal to M L2 T minus 2 a to the power minus 2. So our option A is correct answer. Next up, question number 7. Different devices connected to an AC source are listed in the first column and different phase relation of electric current with the voltage are listed in the second column. Choose the correct match. In first column we have AC source and in second column we have electric current. We have to match these following. Okay. Now we have first one as resistor. We have to match resistor with which one? With the column 2. So we can see in first column we have resistor, inductor, capacitor. So for capacitor we already know it leads the voltage by pi by 2 and also for inductor it lags behind the voltage by pi by 2. Next remaining is resistor. So we can say resistor is in phase with voltage. We already know these three by the phasor diagram, right? Resistor, for resistor, inductor and capacitor we derived a separate equations, then we draw a phasor diagram. From that we can say option C is our correct answer. Okay, next question number 8. The expression for displacement current is given by, which is the expression for displacement current? Know that ID is equal to epsilon naught d phi E by dt. Okay, question number 9. The objective lens of diffracting telescope is a dash and the magnifying power of the telescope for normal adjustment is. These are our option. We have to find the correct answer here. Okay, here the correct answer is, you know that magnifying power M is equal to F naught by Fe, but we have in option C and option D we have M is equal to F naught by Fe. So we have to find whether it is large aperture or small aperture. There in the question they have given refracting telescope and magnifying power of telescope. So we can say the option C is correct. It is convex lens of large aperture M is equal to F naught by Fe. Question number 10. Among the given two statements, statement 1, wavefront is the surface of constant phase. By seeing the statement only, we can say first statement is correct. And statement 2 is statement 2 is when the plane wavefront is passed through a thin prism, it emerges out as a spherical wavefront. So these are the options, option A, B, C, D. By the statements only, we can say statement 1 is correct and second statement is wrong. So option C is correct answer. Next, question number 11. In photoelectric effect experiment, the graph of a physical quantity y versus a physical quantity x is a straight line passing through the origin. Then these are the ABCD are the four options. Then from the law of photoelectric effect, what we can say, the intensity of incident radiation is directly proportional to photoelectric current, right? Then according to that question, we have this as our graph. Photoelectric current is photoelectric current versus intensity graph. What is the correct? Our correct answer is Y is photoelectric current and X is intensity of incident radiation. That is, along y-axis we have photoelectric current and along x-axis we have intensity. Next, question number 12. An alpha particle, a proton, an electron and a neutron are moving with the same velocity. Then the particle having longest de Broglie wavelength is option A proton, option B electron, option C neutron, option D alpha particle. These particles are moving with same velocity. Then the particle having longest de Broglie wavelength. Which particle has the longest de Broglie wavelength? We have to find the particle. Okay. Here we know that de Broglie wavelength lambda is equal to h by mv. That is, lambda is directly proportional to 1 by m. Here, for the particle whose mass is less, de Broglie wavelength is longest. So we have to find which particle's mass is less. So mass of alpha particle is 6.64 into 10 to the power minus 27 kg. And for proton, 1.67 into 10 to the power minus 27 kg. And mass of electron is 9.1 into 10 to the power minus 31 kg. And for finally mass of neutron is 1.67 into 10 to the power minus 27 kg. In these four masses, which one is very less value? Here the mass of electron. So since mass of the electron is less, it has the longest de Broglie wavelength. Our correct answer is option B. Question number 13. Rutherford's nuclear model of atom fails to explain. Rutherford model fails to explain origin of line spectra of hydrogen atom. Option D is correct answer. Next, question number 14. Nuclear binding energy per nucleon is. A is the mass number of the nucleus. We have to find the nuclear binding energy per nucleon. Here correct answer is option C, less for both light and heavy nuclei. Question number 15. If Ne and NH are the number of free electrons and holes respectively, then in the case of an intrinsic semiconductor, option A, Ne is equal to NH, option B, Ne is equal to NH, option C, Ne greater than NH, and option D, Ne is very much greater than NH. Here we know that Ne is equal to NH. We already have the expression, that is for intrinsic semiconductor, Ni is equal to Ne, which is equal to NH. That is, number of electrons is equal to number of holes. Option E is correct. Next, fill in the blanks. First one, an example for dimensionless quantity is, that is magnetic stability. Question number 17. A current carrying coil stores energy in the form of magnetic field. Question number 18. The power factor of a series LCR circuit at resonance is equal to unity. The principle of optical fiber is total internal reflection. Next, the bending of light around the corners and entering into geometrical shadow region is called diffraction. Okay, bending of light around the edges of obstacles is called as diffraction. Next, moving to part B. Here 21st question number 21. Define electric flux through an area element and mention its SI unit. You know that it is the total number of electric field lines passing through the given surface normally is called as electric flux. Electric flux means number of electric field lines passing through the given surface. Then SI unit of electric flux is voltmeter. Okay, question number 22. What is meant by equipotential surface? Draw equipotential surfaces for an electric dipole. We know that equipotential surfaces are the surface on which potential is same at all the points. That is called as equipotential surface. For electric dipole, for dipole means for plus sign minus charge. This is the diagram of equipotential surface. Okay. Write any two limitations of Ohm's law. First point is Ohm's law is applicable only when temperature is constant, and Ohm's law is applicable only when pressure is not applied on the conductor. Ohm's law is not applicable for X-ray and vacuum tubes. You can write any two of the following. Next, question number 24. Give the vector form of Biot-Savart's law and explain the terms. That is, dB vector is equal to mu naught by 4 pi I into dl cross r divided by r cube, r square. Okay, here I is the current, mu naught is the permeability of free space, dl is the length of the current element, and r is the distance. Next, question number 25. What is AC generator? What is its working principle? AC generator is a device which converts mechanical energy into electrical energy. Principle of AC generator is electromagnetic induction, that is EMI. List any two uses of infrared rays. It is used in remote control and heater, in solar cooker, physiotherapy, etc. Okay. Next, the radius of innermost electron orbit of a hydrogen atom is 5.3 into 10 to the power minus 11 meter. Determine the radius of the n is equal to 2 orbit. Here we can list out the given values. That is n is equal to 2 and r1 is equal to 5.3 into 10 to the power minus 11 meter. Next, we have to find the radius of n is equal to 2 orbit. So r2 is equal to how much? We have the formula Rn is equal to n square into r1. Now let us substitute the values into this equation. They already given n is equal to 2. So I will substitute in the place of n as 2. 2 square into r1 value is also given, that is 5.3 into 10 to the power minus 11, and after multiplication we get 21.2 into 10 to the power minus 11 meter. Okay. Next is part C, question number 29. Define linear charge density. Mention the expression for electric field due to an infinite line of charge and explain the terms. First we have to define linear charge density. We know that it is the charge per unit length of the conductor. In case if they ask volume charge density, it is the charge per unit volume of the conductor. Okay. Next, the question is continued that mention the expression for electric field due to an infinite line of charge and explain the terms. We know that the expression is E is equal to lambda by 2 pi epsilon naught r. Here lambda is the linear charge density and epsilon naught is the permittivity of free space, and r is the distance between straight conductor and point P. Okay, question number 30. Obtain the expression for equivalent capacitance of two capacitors connected in series. We know that series connection means side by side connection. We have capacitor of capacitance C1 and C2. Here, when the capacitors are connected in series, charge on each capacitor is same. Okay, total potential of series combination is equal to sum of potential across individual capacitor, that is V is equal to V1 plus V2. Consider this one as equation 1. Next we know that Q is equal to C into V. So I will rearrange this one for V. So we get V is equal to Q by C. Okay, then what we can write for V1? V1 is equal to Q by C1, and for V2, V2 is equal to Q by C2. Now we can substitute these three equations in equation 1. So what happens to equation 1? In place of V, we can substitute Q by C, which is equal to, place of V1, we can substitute Q by C1, plus in place of V2, we can substitute Q by C2. Now in the right hand side, Q is common, so I will take Q outside. Next equation is Q by C is equal to Q into 1 by C1 plus 1 by C2. Then from left hand side and from right hand side, Q get cancelled. Remaining is 1 by C is equal to 1 by C1 plus 1 by C2. Here C is equal to CS, that is equivalent capacitance of series combination. Therefore, we can write 1 by CS is equal to 1 by C. Question number 31. Explain the conversion of galvanometer into an ammeter using relevant circuit diagram and expression. Here we have to mainly mention that whether it is parallel or series, and the diagram and the equation. Okay, let us start. Explain the conversion of galvanometer into an ammeter. So galvanometer can be converted into ammeter by connecting very small resistance in parallel with it. That is, we can observe in the diagram. Galvanometer is connected to shunt resistance parallelly. Okay, here S potential difference across S is equal to potential difference across G. So we can write the equation as potential difference across S as I minus Ig, current into resistance value S, which is equal to potential across G, that is for galvanometer Ig into G. I will rearrange this equation. So S is equal to Igg divided by I minus Ig, where Ig is the current through the galvanometer and I is the total current, G is the resistance of the galvanometer. Okay, next question number 32. Write any three difference between diamagnetic and paramagnetic materials. We have to write three difference between diamagnetic and paramagnetic materials. Here first difference is they are weakly repelled by the bar magnet. Paramagnetic materials are weakly attracted by the bar magnet. Next, second difference is that relative permeability is less than 1 and here it is greater than 1. Third point, susceptibility. For diamagnetic material, susceptibility is low and negative, and for paramagnetic material, susceptibility is low and positive. Next, example for diamagnetic materials are gold, silver, diamond, and for paramagnetic material it is sodium, potassium, etc. Question number 33. Derive the expression for the motional EMF induced in a conducting rod moving perpendicular to a uniform magnetic field. Here is the answer. EMF induced across the ends of the conductor when conductor is made to move in perpendicular magnetic field is called as motional EMF. Then we have to draw the diagram. We have L. So L is the length of the conductor. Then the magnetic flux is given by expression for magnetic flux is phi B is equal to BA cos theta. Here theta is equal to 0. So cos 0 degree is equal to 1. So I will write the equation as 5b is equal to ba into 1. Anything into 1 is that value only. So 5b is equal to b into a. Consider this one as equation 1. Next, but we have the area A is equal to L into dx. Consider this one as equation 3. Now I will substitute equation 3 in equation 2. So what happens to equation 2? In place of A, we can substitute equation 3. So 5b is equal to b into, instead of a, I will substitute L into dx. Consider this one as equation 4. Next, differentiate equation 4 with respect to time. So what happens to equation 4? D by dt of 5b is equal to d by dt of bl dx. Our next step is d 5b by dt is equal to, I will take bl this side, so bl into dx by dt. Here we know that dx by dt is nothing but velocity, d 5b by dt is e. So I'll substitute in place of d 5b by dt as e and dx by dt as v. So we can write E is equal to bl as it is into v. E is equal to bvl. V is the velocity, B is the magnetic field, and L is the length of the conductor. Okay, question number 34. Show that the focal length of spherical mirror is equal to half of its radius of curvature. We have to show focal length f is equal to half of its radius of curvature, means r by 2. F is equal to r by 2. This is our ray diagram. Then we have to explain the ray diagram. After explanation, we can consider a triangle PMC. Okay, here we have angle of incidence. So I'll take tan I is equal to, we know that for tan opposite by adjacent side. In triangle PMC, we have opposite side as PM and adjacent side as PC. So my equation 1 is tan I is equal to PM by PC. Similarly, next I will consider triangle PMF. Okay, we'll consider the triangle PMF. Here I have the angle 2i. So again tan is equal to opposite by adjacent. So tan 2i is equal to PM divided by PF. Okay, consider this one as equation 2. In the diagram, I missed F there. Okay, correct it. We got equation 1 and equation 2. So if I is small, I is very small, what we can write? I'll write tan I as I. If the angle is very small, what we can write? Tan I as I and tan 2i as 2i. So equation 1 and equation 2 becomes, equation 1 becomes first. In place of tan I can write I. So I is equal to PM by PC. Equation 3. Next is equal to PM by PF. We got equation 4. Now divide equation 3 by equation 4. Equation 3 by equation 4 means I by 2i. In the right hand side we have PM by PC divided by PM by PF. Now PM get cancelled. Remaining is I by 2i is equal to 1 by PC divided by 1 by PF. I will rearrange this equation. So I get 1 by 2 is equal to PF divided by PC. Next, from the diagram we have along PF we have focal length f and along PC we have radius of curvature r. So I will substitute in place of PF as small letter f and in place of PC r. We got 1 by 2 is equal to f by r. I will rearrange this one for focal length f. F is equal to r by 2, where f is the focal length, r is the radius of curvature. Okay. Next, question number 35. The work function of cesium is 2.114 electron volt. Calculate the threshold frequency for cesium. First, what we have to do? We have to write the given values. We have the work function value as 2.14 electron volt. Then we have to find the threshold frequency. Okay, we know that 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay, now I have this work function value in electron volt, so I'll write W is equal to 2.14 into 1 electron volt value. Okay, we have the formula as W is equal to H into nu naught. I'll substitute the values in next step. Then I will rearrange these values for nu naught, threshold frequency. What happens? We finally get, after calculation, we finally get nu naught is equal to 5.1683 into 10 to the power 14 hertz. Okay, question number 36. Mention 3 features of nuclear force. Nuclear force is strongest force. Nuclear force is attractive in nature, and it is saturated force, spin dependent, non-central, exchange force. These are the features. Okay, next part D, question number 37. Derive an expression for the electric field at a point on the axis of an electric dipole. And derivation, first we have to draw the diagram. After the diagram, let us start the derivation. It is electric field at a point A due to charge plus Q is given by. First, let us write the expression for electric field at point A, then electric field at point A due to charge minus Q. Okay, first for plus Q and next for minus Q. I got first equation as E1 is equal to 1 by 4 pi epsilon naught Q by R minus A whole square, and our second equation is R minus A means that the distance is R there, then below I mentioned that as 2A. So first half is A and next half from 0 to minus Q is A. So here the what distance is R minus A. But for equation 2 or for minus Q, we have R plus A whole square. This is because we have to consider till minus Q charge. Okay, we got two equations. Now net electric field E is equal to E1 plus E2. Let us substitute the values here. Before that, since electric fields E1 and E2 are opposite to each other, we have the values as E is equal to E1 plus into minus E2. Plus into minus is minus, so E is equal to E1 minus E2. Let us substitute first two equations in this equation. We got E is equal to 1 by 4 pi epsilon naught Q by R minus A whole square minus 1 by 4 pi epsilon naught Q by R plus A whole square. Here Q by 4 pi epsilon naught is common. So I'll take Q by 4 pi epsilon naught outside. Remaining is 1 by R minus A whole square minus 1 by R plus A whole square. Next step is we can cross multiply that equation. So R plus A whole square into 1 is R plus A whole square plus R minus A whole square into 1 is R minus A whole square. In the denominator same. Next we can use the formulas here. It is in place of R plus A whole square we can use A plus B whole square formula. In place of R minus A whole square we can use A minus B whole square formula. And below we have R minus A whole square into R plus A whole square. But we know that A square minus B square is equal to A plus B into A minus B. So R plus A into R minus A is equal to R square minus A square. But we have here whole square, so I'll write that one as R square minus A square whole square. In the denominator I got R square minus A square whole square, but in the numerator there plus R square minus R square get cancels, plus A square minus A square get cancelled. Remaining is 2AR plus 2AR. We know that 2AR plus 2AR is 4AR. So we got our next equation as E is equal to 1 by 4 pi epsilon naught 4QAR. I can split that 4 into 4 as 2 into 2. Now I got a equation as 2QA into 2R. We know that dipole moment P is equal to 2QA. So in place of 2qa, I will write P. So E is equal to 1 by 4 pi epsilon naught P into 2R divided by the terms in the denominator. Here R square is very much greater than A square. So here A square is neglected. Remaining is E is equal to 1 by 4 pi epsilon naught 2P by R cube, where P is the electric dipole moment and epsilon naught is the permittivity of free space and R is the distance between A and O. Number 38, using Kirchhoff's law, arrive at the balancing condition of Wheatstone network. This is our Wheatstone network. We have the resistances PQ, RS and current values I1, I2, IG, I4 and I3. BA is the battery here. Okay, let us first use KCL. Okay, applying Kirchhoff's current rule at node B. At node B, I will apply KCL. So what happens? I1 current entering, so it is plus I1 again minus IG minus I3. Okay, I applied node rule in B. So I1 minus IG minus I3 is equal to 0. I'll rearrange this equation. So I1 is equal to IG plus I3. Consider this one as equation 3. Next, again applying Kirchhoff's current rule KCL at node D. At node D. So what we can write? I2 plus IG minus I4. Okay, consider I4 which is equal to 0. Then we can rearrange this equation as I4 is equal to IG plus I2. Consider this one as equation 2. Applying Kirchhoff's voltage rule for loop ABDA. Now I will apply KVL to the loop ABDA. What happens in ABDA? I have I1 as the current and P as the resistance. So current entering here, if we are using KVL. So current entering. So I1 into P. This is from A to B. Next again B to D, we have current IG. So there also current is okay, ABDA. For ABDA, then ABDA, we have to, let us write the value of I2. First I wrote current entering, that is I1 into P. Then for I2, the current is leaving the circuit, so it is minus I2 into R. Then finally it is current through the galvanometer. It is entering the circuit. That arrow mark represent current entering the circuit. So plus IG into G, which is equal to 0. I'll rearrange this equation for I2R. I get I2R is equal to I1P plus IGG. Consider this one as equation 3. Similarly, for Kirchhoff's voltage rule for BCDB loop. BCDB. In BCDB, B to C, current leaving the circuit. So, I will write minus I3. Okay, minus I3Q. Okay, sorry. From B to C, current entering, that is we have current value I3 and resistance value Q. So plus I3Q, then C to D, again it is current leaving. So I4 into S minus I4 into S. From D to B, again it is current leaving, so minus IG into G. I got equation 4 now. By rearranging that above equation, I got equation 4. Now we know that balance condition for Wheatstone bridge is current through the galvanometer is equal to 0. So IG is equal to 0. I'll substitute IG is equal to 0 in equation 3 and equation 4. I got equation 5 and equation 6. Next, we have from equation 1, we have I1 is equal to I3. And from equation 2, I2 is equal to I4. I'll substitute these two in equation 5 and 6. Then I get I1P by I3Q. Okay, dividing equation 5 and 6, I1P by I3Q, which is equal to I2R by I4S. Then what happens? We already wrote I1 is equal to I3. So I consider I3 as I1. So I1 get cancelled, which is equal to I2 is I2 by I4. I4 is equal to I2. I2 by I2 get cancelled. R by S. P by Q, which is equal to R by S. Okay, next question number 39. State and explain Ampere's circuital law and derive the expression for magnetic field at a point due to an infinitely long straight current carrying wire using Ampere's circuital law. According to that law, we can write the expression line integral VDL is equal to mu naught into I. Then terms explanation, I is the current and mu naught is the permeability of free space. Next, the derivation for magnetic field. Okay, here in this diagram, I is the current and R is the distance. Now we have Ampere's circuital law as line integral VDL is equal to mu naught into I. Then we have circumference of this loop as line integral dl. Line integral dl is equal to 2 pi r. So what I can do, I can substitute. I am explaining about Ampere's circuital law only, about first equation only. Okay, here I told line integral dl is equal to 2 pi r, that is circumference of the loop. Now I can substitute like line integral dl as 2 pi r. Remaining is b in the left hand side. So in left hand side I have 2 pi r into b, which is equal to mu naught into I. I want the expression for magnetic field. So I will rearrange that equation and get V is equal to mu naught I divided by 2 pi r. It is so simple derivation. 40. Derive the expression for refractive index of the material of a prism in terms of angle of the prism and angle of minimum deviation. First we have to draw the diagram. Then we have to explain that diagram. After explanation, okay, let us start the derivation. First let us consider Snell's law. We know that n is equal to sin I by sin r. Consider this one as equation 1. Next I will take deviation at the surface AB. In diagram observe AB side. Here I have the deviation along first side AB. So I denoted that one as D1. D1 is equal to, I have I1 minus R1. Now deviation at second side, that is along AC, D2 is equal to I2 minus R2. Now I got the expression for D1 and D2. I can write the total deviation D as D is equal to D1 plus D2. I can substitute D1 and D2 value here. After removing the bracket, I will group the terms I1 and I2 together, R1 and R2 together. So I got equation 2. After equation 2, I can consider from this diagram I1 is equal to I2, which is equal to I, and R1 is equal to R2, which is equal to R. Then I will denote that deviation as minimum deviation, capital D or DM. Next, let us consider the triangle QTR. In the diagram, let us consider QTR. We know that along A, we have 60 degree. So I will write R1 plus R2 plus QTR, which is equal to 180 degree. Okay, I'll consider this one as equation 4. Next, again I will take from quadrilateral AQTR, I will take A plus QTR. Okay, A means 60 degree, already we know that 60 plus that obtuse angle. So obtuse angle 120 degree. 60 plus 120 is 180. Equation 5 I got. Now from equation 4 and equation 5, comparing equation 4 and 5, what we can write? Along left hand side we have R1, R2, okay, and along right hand side A. Because QTR get cancelled, 180 get cancelled. Remaining is R1 plus R2 is equal to A. And in equation 3 we already wrote that R1 is equal to R2, which is equal to R. So I'll substitute in place of R1 as R and R2 as R. So I get R plus R is equal to A. R plus R is 2R. 2R is equal to A. Again I rearrange that equation. A is equal to, R is equal to A by 2. Consider this one as equation 7. Then substitute equation 3 and 6 in equation 2. So what happens to equation 2? In place of small letter d, I can write capital letter D, which is equal to, in place of A, I can write 2I minus A. Now, I will rearrange this equation for angle of incidence I. I is equal to A plus D by 2. Consider this one as equation 8. Now, equation 7 and substitute equation 7 and 8 in equation 1. Snell's law, that is n is equal to sine of A plus D by 2 divided by sine of A by 2. Thank you.